Good morning and welcome to Algebra 1A. Today we're going to review the homework, which was identifying functions from relations. And then I'm going to talk a little bit about function notation and how we use some functions. So first, the quick answers on the table page, the functions from tables. 1 is a function, 2 is not, 3 is not, 4 is, 5 is, and 6 is not. The reason why any of them are not functions is because there are inputs, x values, that get more than one output, y values. For instance, in number 2, the input of 9 repeats itself twice, but every time it does, it has a different output, negative 18 versus 17. It's not a function. It's only a function if every input has only one output. Turn the page to the ordered pairs side. Again, we're looking for whether or not the inputs repeat. And if they do, if they repeat with a different output. So on the ordered pairs side, number 1 is a function, number 2 is not, 3 is not, and 4 is. 5 is not, and 6 is not. 7 is, but 8 is not. And again, the answer is always the same. If an input repeats with a different output, it is not a function. On the graphs down below, 1, 2, 3, you're looking to see whether or not it passes the vertical line test. Number 1 does not. Number 1 fails because an input of, it looks like it says negative 8, has two different outputs at negative 8 and 12. The second graph is a function. None of those points form a vertical line. Number 3 also is a function. None of those points form a vertical line. Last page is the mapping. You're looking to see if there are more than one arrow from any input. Number 1 does not show any problems. Number 1 is a function because every input has only one arrow leaving it. Number 2 breaks that rule though because the input of negative 9 has 2 arrows leaving it, not a function. Number 3 is not a function. The number of 0 has 2 outputs, 17 and 19. Number 4 is a function because it doesn't have any issues. There's only one arrow leaving each input. Number 5, also fine. Every input has only one arrow leaving it. And number 6, not a function because, let's see, it says not a function. I'm kind of disagreeing there. I don't know why the number 0 is there in the domain because it has no output. Maybe that's an issue for whoever made this answer key. However, other than the number 0 not having any place to go, it doesn't appear to break the rule of having more than one output for any one input. So I'm going to go with, I'd say, yeah, it's a function with the exception of why that 0 is hanging out in the domain if it has nowhere to go. Okay. Questions or problems, issues or concerns, of course, log into the Google Meet and tell me, because right now we're moving on to the next little piece. So here's what I want you to know, all right? And it's not especially difficult, but it's quite useful. I know that you guys understand that this is an equation, a nice, easy equation. We can plug in numbers for x and figure out what we get on y. It's not a problem. If I made a little table of values and I chose some inputs for x, I'm choosing to choose 0, 1, and 2. I'm going to plug them in and see what I get. So if I plug in the number 0 as x, 2 times 0 is 0, and 0 plus 4 is 4. If I plug in the number 1 for x, 2 times 1 is 2, and 2 plus 4 is 6. And if I plug in the number 2 for x, 2 times 2 is 4, and 4 plus 4 is 8. It's not a big deal and it's not new. But we are going to talk about functions now specifically. And oftentimes we name our functions using this whole input-output rule or philosophy. Here's what we could say instead. Instead of y equals 2x plus 4, we could write this, and it's read as f of x equals 2x plus 4. These are the same equations. F of x. All this means is there's a function. We usually default to the letter F, but other letters can be used. There's a function that takes an input. That's why it's read f of x, the function of x. And it does this to the input. It doubles it, and then it adds 4. It's basically the same thing as the other equation. Here's the way the questions are asked that also are a little different. Instead of saying, what do I get when I plug in 0, 1, and 2 using a table, I can ask you questions like this. Just going to skip the 0 for a second. Now, that is a question that says f of 1. What it means is this. It says if you take an input of 1 and plug it into the function, what do you get? This one says f of 2. If you take the number 2 and you plug it into the function, what do you get? So here's what you would do. You would plug the number 1 in place of the x. And you would get an answer that f of 1 equals 6. Now here's where I need you to, again, listen in. That problem is finished. F is not a variable. You're not trying to get f by itself. You're not going to divide by 1 and get rid of it. That's not what it's saying. It is notation. It is saying when the function gets an input of 1, it gives you an output of 6. So let's try the second problem here where it says f of 2. You're plugging in the number 2 for x, and you're solving it. So f of 2 equals 2 times 2, which is 4, plus 4 more, which is 8. That is the solution. You will not divide both sides by 2 to try to get f by itself. F is not a variable. F is the letter that says the function that you've got right now takes as an input the number 2 and gives you as an output the number 8. So with function notation, you're given an equation in function form, and you could be asked to solve it in function form. So here's another example for you. Let's say here's the function f of x equals 1/2 of x minus 2. All right, so you've been given a function. You've been told what it does. It's 1/2 times the x minus 2. So my question is solve for f of 10. Why don't you pause the video, solve it, and restart the video. Do that now. If we're solving for f of 10, we need to plug in the number 10 in place of x. So that means it's 1/2 of 10, which is 5, minus 2. So f of 10 equals 3. Again, don't try to divide both sides by 10. Don't do that. This problem is solved. Function notation tells you that the function takes an input of 10 and gives you an output of 3. Okay. There's another way a question can be asked, and it's different than this. In fact, I'm going to leave this on the board while I do the other one. So the other way a question can be asked is not to say, what is f of 10? But it could say, f of what number will equal 10? Now, these are two different questions. F of 10 says plug the 10 in place of x and solve. This one asks you what x can be to get an answer of 10. So here's what you do. You write down that function f of x, which is 1/2 x minus 2, and you make it equal 10. See what I did? I took the function. See, it says f of x equals 10. Well, f of x is 1/2 x minus 2. So 1/2 x minus 2 has to equal 10. Now we're going to solve for x. So we're going to add 2 to both sides. And I get 1/2 of x equals 12. To clear a fraction, we have to multiply by the denominator. So I'm going to multiply this whole thing by the number 2. That clears the fraction, and 2 times 12 is 24. So please note how these are different, all right? In the first problem, you were told what the input needs to be, so you plugged it in and you solved f of 10 equals 3. In this problem, you're told what you want the equation to equal, and you got to figure out what x is to get that answer. So you write down the function, and you make it equal 10. And then we solve for x. We add 2 to both sides. We cleared the fraction by multiplying by the denominator of 2, and we got x equals 24. So double check it. Half of 24 is 12, and 12 minus 2 is 10. It worked. So again, you can have one function, but you could be asked 2 different questions at the same time. So let's try one more, and then we'll call it a day. This time my function is going to be named g. So g of x equals negative 3x plus 8. So I want you to find g of 2, and I also want you to find g of x equals negative 1. So there's 2 problems here. Solve for g of 2, and then solve for g of x equals negative 1. So pause, solve, and replay the video. Do that now. To solve g of 2, I'm going to plug in the number 2. So negative 3 times 2 plus 8. So g of 2 equals negative 6 plus 8. Turns out g of 2 equals 2. Coincidental, not on purpose. G of x equals negative 1 says make the g of x function equal negative 1. So I'm going to write down the function negative 3x plus 8 equals negative 1. And now it's just an equation to solve. So I'm going to subtract 8 from both sides. And I get negative 3x equals negative 9. I'm going to divide both sides by negative 3 to get x by itself. X equals 3. So an input of 3 will get me an output of negative 1. That's the new material for the day. There's no homework today. We'll continue tomorrow with this concept, with some practice work to do. Please make sure you understand what's going on and ask me if there's any questions. Feel free to log into the Meet if you watched this video beforehand, and you're always welcome to join us. Otherwise, have a great day.